Hello and welcome to the 6th lecture in the module Reason and Persuasion. And this week I want to talk a bit about inductive reasoning, including causal reasoning, analogical reasoning, and I'll say a word about statistical reasoning. So inductive reasoning is usually or traditionally defined as reasoning from particulars to generalizations. So for example, a standard example of inductive reasoning is that every swan I've seen before so far is white, therefore all swans are white, right? So you're going for some finite collection of cases. I've seen some finite number of swans, and then you're generalizing to a possibly infinite totality. All swans are white, right? Now, as you may know, there are black swans, right? So inductive reasoning isn't always reliable, so it's a good question which are the good inductive arguments. But the reason why no inductive argument is ever completely reliable is that inductive arguments are ampliative, right? Like this fine machine, inductive arguments, ampliative arguments, they give you more than you put in. They give out more than they put in. More technically, there's more in the conclusion than there is in the premises. So in our swans example, there was only a finite collection of swans in the premises, but a much bigger collection, possibly infinite collection of swans in the conclusion. Okay. So we were talking about fallacies last week. There are fallacies associated with causal reasoning. And one of them is the fallacy of coincidental correlation, also called in Latin post hoc ergo propter hoc. And that's the fallacy of thinking, well, if two things go together, one of them must cause the other. One standard example is most heroin addicts also smoke marijuana. So you might think that smoking marijuana causes people to become heroin addicts. But the mere fact that there's that correlation doesn't establish that there's a causation. A notorious case was the MMR jab causing autism. Well, children have the MMR jab at about the same age that autism symptoms manifest themselves. So if you're the parent of a child who develops autistic symptoms, the time sequence is there that you took your child for the MMR jab, and then shortly afterwards they develop the autism symptoms. But so it looks like causation, but it doesn't follow, and in fact there's no connection. On the module site there's a link to a website which is collects examples of correlation that can't possibly be examples of causation. Okay, so that's the fallacy of coincidental correlation. Just because two things go together doesn't necessarily mean that one causes the other. But causal reasoning is really difficult. It's really difficult in things like medicine, right? Because why? Well, because living organisms are causally very complex. Your body is an immensely complex collection of systems. It's systems within systems within systems of things causing each other. So if you go to your doctor and say, well, I've got these symptoms, I've got a bit of a rash and a slight temperature, and I feel a bit off colour, maybe it's a food intolerance, maybe it's some environmental thing, maybe you've been in contact with fiberglass. You know, there's a gazillion things it could be. And it's particularly difficult to do causal tests on the human body because your body is full of fail-safe systems. So if one system stops working, your body will very often kick in some other system to do the same job so that you don't die, which makes causal reasoning quite hard. So the point is that in the laboratory, you may be able to stabilize and hold still all the various causes and effects to isolate the ones you want to study. But in nature, these things all kind of run together, which is why John Stuart Mill identified 4 methods for causal reasoning. And the thing you need to know about John Stuart Mill's 4 methods is that really you need to use all 4 of them together, because otherwise you are vulnerable to coincidental correlation. John Stuart Mill, by the way, I mean, he's famous for utilitarianism, which is a sort of relatively, well, dry and calculating approach to ethics. He's also famous for this stuff, which is a kind of dry and calculating corner of logic. And for On Liberty, which if it was published now would be called something like The Little Book of Liberalism, which you all ought to read. Everybody ought to read On Liberty, especially now, because it is a little book and it articulates the case for liberalism very powerfully. But he did write rather long Victorian phrases. He wrote sentences that work more like paragraphs. So it's easy to forget that he was a rather passionate person in his own way, and he had a passionate relationship with a woman called Harriet Taylor, which I think is one of the great romances of the history of philosophy. Anyway, Mill's methods, Mill's 4 methods for causal reasoning. So the first method, the method of agreement. So what he says, if 2 or more instances of some phenomenon A have only one circumstance B in common, the circumstance B in which alone all the instances agree is the cause or effect of the given phenomenon A. All right, so what about these A's and B's? Well, so I'll use big nights out drinking and their consequences as a source of examples. This in no way endorses excess alcohol intake as a lifestyle, nor do I assume that this is something that all students do. Okay. So if somebody goes out several nights, one night they have big beers and a kebab, wake up next morning feeling rough. Next big night out, they have big beers and a pizza, wake up next morning feeling rough. Next night out, they have big beers and a curry, right? Wake up next morning feeling rough. Well, what have they got in common? It's the big beers. And so you can reasonably surmise that it's the big beers that are the common circumstance that is the cause of the common effect, namely feeling rough the next morning, right? So that's the method of agreement. What these big nights out have in agreement is the big beers. Where they differ is the different accompanying late night food. So it's the common thing, the big beers, that cause the hangover, right? That's obvious enough. But of course, you are vulnerable, if that's the only method you use, to coincidental correlation. And there is the case of the person who drank, wine and water and felt rough, and the next time drank whiskey and water, and next day felt rough, and the next time drank rum and water, and the next day felt rough. So obviously it's the water, right? Obviously the water is the cause of the hangovers if you just apply the method of agreement on its own. This is why we also need the method of differences. So the method of differences says, if an instance in which the phenomenon A occurs, and if an instance in which A does not occur, have every circumstance in common apart from one, then B is the effect or the cause or an indispensable part of the cause of A. So what about these A, B's, C's and D's? Well, let's suppose that A is the hangover. Right, so you have a big night out where A occurs and another big night out where A doesn't occur. And on the first night, you have a cup of tea and a sandwich and some beers and a Coke and a kebab on the way home. And the next morning you feel rough. And another night out, you have a cup of tea and a sandwich before you go out, and a Coke, but no beers, and a kebab on the way home. And the next morning you feel fine. Well, what was the difference between those two nights out? It was the beers, right? So that confirms your suspicion that you got from the first experiment, that it's the beers that are the cause of the hangover, right? So that's a test you can run. If you think you've got a correlation, you think you've got a causal relationship by using the method of agreement, then you can check, you knock out the thing that you suspect is the cause and see if the effect goes away, right? So the person who thought that water was the cause of their hangovers could try drinking wine, whiskey and rum neat and see if their hangovers went away, and obviously they won't. So that disproves the hypothesis that water is the cause of the hangovers, right? So you need agreement and differences if you have a hypothesis using the method of agreement, use the method of differences to test it. Is the method of residues. So what does he say? Subduct from any phenomenon A such part B as is known by previous inductions to be the effect of certain antecedents D, and the residue C of the phenomenon is the effect of the remaining antecedents E. Okay, so now we've got A, B, C, D, and E. What does that mean? Well, supposing you know from prior experience that when you go for big nights out, supposing you normally have, just a load of beers, and that normally gives you a bit of a hangover the next day, but this time you have some beers and a pizza, and the next morning you have the usual hangover symptoms plus some red stains on your shirt. Okay, so the headache and the dizziness and the aversion to sunlight and the dry mouth, that's all caused by the beers. I can set those aside. Then the residue, the red stains on my shirt, must have been caused by the pizza. And actually, yes, they do smell faintly of tomato. So they're tomato sauce, right? Okay, so the method of residues is if you've got a complex, right, this is part of the point. This is for thinking about complexes of causes and complexes of effects, right? So a lot of the time in philosophy, when people talk about causation, they talk about a cause and an effect. But that's not what life gives you. Life gives you a bunch of stuff happening, and a bit later, a bunch of other stuff happening, right? And maybe the stuff that happened, maybe the complex, the whole collection of stuff that happened earlier is causally related to the stuff that happened later, but in complex interacting ways. That's what real life is like. Real life isn't like one snooker ball tapping into another and causing a single movement, right? So the method of residues is just meant to help you disentangle causes. Now, causes and effects, where you get a bunch of possible causes and later a bunch of possible effects. If you know that some of the effects were caused by some of the things that happened earlier, then the other things that happened later must have been caused by some of the other things that happened earlier, right? This isn't tremendously deep stuff. This is mostly a matter of just putting labels on modes of analysis that you're already aware of, right? Okay, the last one. Now notice that the first three of these methods was just about whether a cause was present or absent. I haven't talked about how much you drank or how bad your headache was, right? It's either the pizza is there or it isn't. Either in the causes, either the pizza stain on your shirt is there or it isn't, right? I've been talking about things being either present or absent, either on or off. The last of Mill's four causes is the only one that is quantitative, right? That talks about how much. And that is the method of concomitant variations. So whatever phenomenon B varies in any manner with another phenomenon A, B is either a cause or an effect of that phenomenon, or is connected with it through some fact of causation, right? In other words, if two things vary together, then possibly the one causes the other. And this might be a positive correlation, like the more beer you drink, the worse your headache is. Or it might be a negative correlation, like the more water you drink over the course of an evening, the less your hangover is, right? So water drunk over the course of a big night out will be inversely proportional to the severity of your hangover. Okay. But again, as always, all of these four ideas are vulnerable to post hoc ergo propter hoc unless you check them against each other, right? So if you want to establish a causal relation, you need to make sure that you use all, more than one, and preferably all four. Okay, so take a moment now to make sure that you've understood these four distinct methods and that you've got your A, B, C's, D's, and E's sorted out, and think of a few examples of your own, and then I'll talk about some other points about causal reasoning.